Hey guys, how's it going? Let's talk about our last two reaction types. We're not going to get through all the way through both of these. Essentially, as you can see on the screen there's a bunch of different types, 5 different types of synthesis reaction. But it's easier than it looks, it's less daunting than it looks. So start by writing down what you see on the screen. I'll obviously pause the video. Okay, so let's talk about what each of these means. First of all, the word synthesis means to make. So we're making something, um, and a synthesis reaction you're going to be able to recognize because you're going to always end up with just one product. So you're putting together two things to make one product, all right? And what those two things are is going to determine what that one product is, obviously. So first of all, synthesis reactions are usually exothermic. They usually give off energy because you're going down in energy. You start with high energy elements or just unstable compounds, and you end up with stable low energy compounds or a single compound. Okay, so the first type of synthesis reaction is the simplest. A free element plus a free element yields a binary compound. So binary means two, so it's going to contain two elements. So an example of this might be magnesium reacting with oxygen to give us magnesium oxide. And that's it. Very simple. Two elements come together, form one compound. That compound contains two elements, the magnesium and the oxide from the other side. We just have to balance with a 2 in front of magnesium oxide, and then it looks like a 2 in front of magnesium, and we should be good to go. So that's free element, meaning a pure element plus another free element gives us a binary compound, binary meaning two elements in it. Okay, the next type is metal oxide plus water yields metal hydroxide. Okay, so a metal oxide is just exactly what it sounds like. It's a metal paired with oxygen. Okay, so for example, we might have copper 2 oxide, so CuO. That would be a metal oxide. And actually, just to kind of keep things consistent, maybe I'll slide that over underneath its name, metal oxide. And then, of course, water is water. And it's going to make a metal hydroxide. Okay, so metal hydroxide would be that same metal that we had on the left, copper with a 2 plus charge, and I know that it's copper 2 plus because there's a 1-to-1 ratio with the oxide, which is 2 minus. So this is copper 2 plus, and hydroxide is 1 minus. So hydroxide refers specifically to the polyatomic ion hydroxide, so OH 1 minus. And so we are going to need 2 of those hydroxides. Okay, and just get rid of the charges if I can without messing up my formula, and then balance the equation. So, and actually this one looks like it's already balanced because we've got 2 hydrogens on each side, we've got 2 oxygens on each side, 1 copper on each side, so we're good to go. Now, before I go any further, how are you going to be able to tell that this is a synthesis rather than a single replacement reaction? Well, rather than a double replacement reaction, because in a double replacement reaction, we also have 2 compounds. Well, if one of those compounds is a molecule, namely water in this case, it's not going to be a double replacement reaction. You're going to treat it like a synthesis reaction. Okay. If it's ionic, so if you have copper 2 oxide is ionic. If this next substance over here is an ionic compound, let's say sodium chloride, you know it's a double replacement reaction. But if it's a molecule, it's not. It's going to be synthesis. Okay. All right, the next up is what happens if you have a metal oxide, so same format as the previous one, but this time we combine it with carbon dioxide, okay? So we'll make up another metal oxide, let's say aluminum oxide. So Al2O3, carbon dioxide is, of course, CO2. It's going to form a metal carbonate. So that just means the metal in this case, of course, would be aluminum. Carbonate is carbonate, CO3 with a 2 minus charge. And since carbonate is 2 minus and aluminum is 3 plus, I'm going to need those subscripts 2 and 3. This one might be a bit more difficult to balance. It looks like we've got right now aluminum is balanced. Carbon is not, so we've got 3 on the right. So maybe put a 3 out in front of CO2. And then that's going to give me, it looks like 6 plus 3 is 9 oxygens, and I have 3 times 3, which is 9 oxygens on the right. So there we go. The next type, we have a metal chloride plus oxygen yields a metal chlorate. So a metal chloride would be, just pick a metal, let's say iron 3. And then chloride is 1 minus, so I'm going to need 3 chlorides. Combine that with oxygen. So it kind of looks like combustion because we're combining with oxygen, but that's not a hydrocarbon there. Okay, so it's a metal chloride plus oxygen. It's going to make a metal chlorate. So in this case, of course, the metal is iron with a 3 plus charge because that's what it was on the other side. And the chlorate is just the polyatomic ion chlorate, ClO3 with a 1 minus charge. And then you just have to balance the charges. So if I have 3 plus on the iron and 1 minus on the chlorate, excuse me, I'm going to need 3 chlorates. And then just get rid of the charges. And then balance the equation if needed. Okay, so let's see, we've got 3 chlorides, 2 oxygens, 9 oxygens. So that's kind of a weird situation. So we might have to do something a little special here. We might have to give this a 4.5 to give us 9 oxygens. And then if that's the case, we got to double everything, right? So this becomes 2, 4.5 becomes 9, and then 1 becomes 2 at the end there. Let's just double check. I've got 2 irons, 2 irons. I've got 6 chlorines. 3 times 2 is 6 chlorines. And then I've got 9 times 2 is 18 oxygens, 18 oxygens. And then it can't be reduced, right? Because I have 2 and 2, but I also have 9. We're not going to talk about the last 2 types right now. Those are a bit more complex. These are a little bit more straightforward, very formulaic, A through D of the synthesis types. So we're going to save E and F for in class next time. But let's talk about decomposition. Decomposition is the exact opposite of synthesis. So if synthesis is making smaller things into one big thing, decomposition, as the name implies, is decomposing it or breaking it down. So start big and end small, end with multiple small pieces. So what you're going to see when I flip to this next page is essentially the exact opposite, a mirror image of all of these notes. Decomposition reactions are going to be endothermic. The first type, instead of free element plus free element yields binary compound, is going to be binary compound breaks down into free element plus free element. So it's not really new. If you could kind of follow what we were doing on A through D up here, you should be able to follow it for decomposition, but we're going to go through, take the notes, and also do a couple of examples anyway. Okay, so there are your notes. Go ahead and pause to copy those. And by the way, I didn't say this a minute ago, but for the for the last 2 types, E and F, leave yourself a little bit of room because it's going to take a little bit more working out. So leave yourself a little more room than just for one reaction underneath E and F if possible, if it's not too late. So go ahead and do that now. Okay, so let's go through and give examples. So a binary compound, so this could be a lot of different things. Let's say we have lithium bromide. So that's going to break down into free element lithium and bromine. Very simple, except bromine is diatomic. So we will have to put a 2 on the as a subscript when it's by itself. And then that means balancing wise, we're going to need 2 lithium bromides and 2 lithiums. All right. And then the next one is also just a flip of what we did with synthesis. So before we were making metal hydroxide, well, what if you added heat? And that's why we said this reaction is endothermic. What if you added heat to break down metal hydroxide? Okay, so let's say you started off with calcium hydroxide. So you're going to get a metal oxide, and of course, in this case, the metal is calcium. Calcium is 2 plus, oxide is 2 minus, so that's just going to be 1 to 1, and we're going to get water. Balancing wise, it looks like this one is balanced. We've got 1 calcium, 2 oxygens, and 2 hydrogens on both sides. A metal carbonate. So let's pick a metal we haven't used yet. Let's go with cobalt. So let's go with CO. Let's go with cobalt 3. So CO2, CO3, 3. Okay, and so I did those subscripts because carbonate is -2. Cobalt in this case, I'm calling it +3. It's a transition metal. That's going to make metal oxide. So if I have cobalt 3 with a 3 plus charge, paired with oxide, which is 2 minus, that's going to be CO2O3, and carbon dioxide. So let's see if this one's difficult to balance. We've got, I don't know, my cobalts are balanced. Let's go to carbon. Carbon, I've got 3 and 1, so 3 in front on the right. Oxygen, I've got 3 and 6, so that's 9, which matches the 9 there, so we're good to go. So then lastly, metal chlorate. We already did the reverse of this one. Let's pick another metal. Let's go with strontium. So strontium is 2 plus. Chlorate is the polyatomic ion, ClO3, 1 minus, so I'm going to need 2 of them. And it's going to make strontium chloride and oxygen. Balancing wise, looks like my chlorines and my strontiums are already balanced. Oxygen, my strontium and my chloride are already balanced, pardon me. Oxygen, I've got 6 on the left, so I will need a 3 on the right. And again, all of these are just the opposite of synthesis. So if I wanted to do any of these reactions, it's going to be endothermic. It's not going to happen naturally because I have to add heat continually to get the reaction to happen, because these compounds on the left were already pretty stable, pretty low in energy. So we're kind of pushing them uphill in terms of energy. And just like I said with synthesis, we're going to talk about these last two with the salts and the oxy acids next time in class. So just be ready with your questions about these first 4 types that we talked about. And then we'll talk about the remaining 2 on Monday.